at this point, I wanted to also emphasize a few key points on the Smith chart, essentially based on what we just discussed. So here's again the real and imaginary axis. And let's look at the center point. The center point clearly has a gamma L of 0. This is the origin. And gamma L of 0, if you actually look at the real and imaginary part of the load, if I look at this circle, it gives me a real part of 1. And if I look at this part of the circle, this is essentially an infinite circle with an XL of 0. So that means that ZL on this origin is going to be equal to 1. As it should be, because a gamma L of 0 means 0 reflection, which means a matched load, which means that my normalized ZL should be equal to 1. Another interesting point is basically the point on the right edge of the circle. Here, obviously, my gamma L is 1. Real part is 1, imaginary part is 0. And that means that this guy represents an open circuit. We have actually seen that the gamma L of 1 represents an open, which, as it should be, my ZL should be equal to infinity. And indeed, if you were to look at the real part of this, essentially that corresponds to infinity, and the imaginary part is basically irrelevant. Let's look at this guy here, gamma L of negative 1. So gamma L of negative 1 is a short. So the short is represented on the other side of the edge of the circle. Now here, if I look at the real part of ZL, which is this circle here, that basically will be equal to 0. And of course, the imaginary part is also 0. So this is basically my short. Equivalently, you can study this point here that has real part of gamma L to be 0, imaginary part of being 1. So this is the gamma L equals J point. And if you basically look and read the load from the Smith chart, you will read essentially that the real part belongs on this circle, which again, this circle has a real part of 0. The imaginary part belongs on this circle. This circle has imaginary part of 1. And so that means that this ZL corresponds to J. Similarly, the bottom point, the one that has gamma L of negative J, also corresponds to ZL equals negative J. And again, you read that exactly the same way. I'm still on the circle with real part of basically 0. Now my imaginary part is this guy here. This guy here has basically a number of negative 1. So what I'm doing on all of these points over and over again is I'm putting essentially a point on the Smith chart, and then I'm reading the two families of circles to find out what load corresponds to that point. And since this is the real and imaginary part of gamma, I can also read immediately what is gamma L.